Oh shit. I gotta test everything just to make sure it works. Give me a second. Give me a second. Test. Test. Okay, we're good. Guys, today I have something special for everybody to see. So, now it's oh, okay. Showing off the encryption program today. That's what I'm doing, guys. Showing off my encryption program that uses slices and shit. Wow, look at this code right here. I'll go ahead and explain how everything works right now. It's kind of a prototype. I need to work on it a lot, but anyway. I think we should change this to salt. Because salt is like something you add throughout, but like a hash is like, I feel like something you would add at the end. Unless a salt's like a thing that you add at the end. I fucking don't know the terminology. Who cares? I just know I'm adding shit to this anyway. So what this program does is pretty simple. It will take a string that you put in and scramble it and hash it. Well, hash, scramble, and I kind of want to add in a section where we scramble it before it gets hashed for even more chaos. So we're going to do that today. We're going to work on this program in particular, which is really just a basic encryption program. So I'll show you all how it works, what it does, and everything like that right now. So if I run /encrypt in my terminal, it will pull up this. Well, I'll go ahead and zoom it in so everybody can see this shit. So I have, there we go. This is beautiful. So you have encrypt, decrypt, and advanced, which decrypt and advanced don't do shit right now. I haven't gotten that far in programming this, obviously. I started working on it yesterday. So if I just put in 1, it'll take me to that, give me X to quit. If I hit X, it allows me to exit. Pretty nice, pretty simple. Well, /encrypt, we can go ahead and hit 1 to start encrypting shit. And there is a bug right now where it prints this line twice. Don't worry about it, guys. This is typical shit for this program. But what I'll do is I'll just put in some pretty basic stuff. Like, let's say I want to type out something like, Gordon, make me a sandwich. The Half-Life 2 right here is insane, right? So then, boom. What the fuck does this even say anymore, man? We just take the word and it's gone. San. You can tell it says san, which is part of sandwich. Now, this is just the preliminary steps, right? So I was going to take, like, different, take the ASCII codes and scramble those up, or shit like that. Also, because this is a prototype, it's displaying how it's going to do it. The final version, which I'm going to distribute for this, won't even include this shit. I don't want people to know what's going on under the hood, because then you could reverse engineer it super easily. So I want to try to obfuscate that as much as possible. I don't know much about how to do that, though. Obviously, just distributing an executable would be the way to go. So we can actually, because I have it set up to where you can see what happens under the hood, we put in, make me a sandwich. Gordon, make me a sandwich, right? Takes that and divides it down and it gets 4. So well, that's the length. Actually, that's the size of the word, right? So it takes that. Then the next one is going to be this. Then this. And it includes spaces in this count where it divides everything up and gives us the 4 number, right? So then that gives us an S length of 25. So the entire word is a length of 25. The batch is going to be 4. The batch is 4. So every segment of it is 4. Then in the working string, which is like literally just the batch, of this. It's a slice that it takes, puts out the word gourd from Gordon, and then takes, adds on the first hash, which is going to be capital G, lowercase g. Reason I did it that way is because when I go to make the decryptor, I think we should just have some pretty simple stuff that it can understand. Obviously, it needs to know what that key is, and it makes it easier for me to see where that initial key is, but you would take the array of, you'd take index 1 of your array, which in this case is GGG, or the first thing that's processed in, and you would do it in reverse. So every step that we do to this has to be done in reverse. So once we take that phrase and put it through here, boom. I'm not sure why I have it set to print out as string hashed and hash string. What? Oh wait, no, actually that makes sense. So, we could say phrase hashed, but so the next one would be 8. It goes up in increments of 4. So an 8, instead of just like, well, the next one, like I said, would be ANM, and a space in the middle, because it includes the space. Obviously, you could exclude the space, but I believe in the way I'm going to do it. I'm probably going to have the space included in there, and then excluded at the end. So that will be pretty interesting. And then, of course, adds in a hash, or as you can see, we have that, adds that, plus a hash to it. So it does the hash first, adds a hash to that, which is just a 3-letter thing from, oh. It's declared in the hash array. So basically, boom, that happens. Same thing here. Adds in ZYN for the hash. Bro, the Zin hash, guys. Hash with Zins. Then there's SAN. Or actually, that's a sandwich. That's from the actual phrase. And then it gets ION, ION, hash with that. And as you can see, it's very quickly not becoming English. Because now you have Gordon make, and it's got like all this extra bullshit in there. Now once we get to the end, right, we have the hash string, and then I'm going to inject a salt on the end. Now, in decryption, right, there's ways of breaking this hash and salt, I believe. And that's by identifying the length of the hash, because obviously somehow you have to be able to decrypt these things. Because you have to be able to be like, oh, well, here's this. But the idea is that you would need to have this shit, which is the hash and the salt. However, that means that both parties who are sharing information using this have to have the hash and the salt. Which is the interesting thing. That's how end-to-end encryption works. Is that you have the keys, and then you have all of the other shit. But this is twice as good as just putting a hash in there, as adding in the salt for extra effect. A salt's basically like a decoy. So if we didn't know that this is the salt, this capital Y, lowercase y is where the salt begins, we'd have no idea that wasn't part of the original statement. That's the idea of the salt, is that if you try to brute force, then obviously you're like, oh shit, there's a hash, but then there's a salt too. So it makes it even harder for a brute force attempt, because you need to have the hash and the salt. That's why I do it first. Technically, you could do it afterwards. And I think if we did it afterwards, that would also work. So I think we'll include another hash salt step, which includes a salt in the middle somewhere, and a hash at the beginning. So that way we can do that. As well as the next step, which will come after this, which will be a second round of scrambling, and another round to make multiple pieces of everything. So obviously, we will want to take the length and divide the length again, to get our next round of operations, which is going to be how many pieces it needs to do. And so I believe somewhere in this, I have an idea. You could technically assign. Let's actually investigate, because here's a problem I've had is the length. Length is a problem. Sometimes if you have a phrase that's too short, for example, if I put in the word 5, which is also 5 letters, short string error right there, which I've designed it to declare that. But of course, there's also, you can get into the encryption, right? And then I haven't even explained the scrambling step, but if we put in like the word like, if we type in Jordan, okay, that went through. It has to be divisible by 6, and then the product that it produces the first time has to be divisible by 8. So there's that issue currently. Like if I put in Todd Howard, it might break. No, it actually comes up. And also in incredibly short statements like this, it's way more effective. Now, if I had a sentence like, okay, like this, it goes to scramble it, but you can still see a lot of the words in there, like trust and great and shit like that, which we don't really want in there at all. In fact, we want to get rid of that. So when we have that, like especially in the hash phase, in that initial hash phase, that's absolute shit. So when we get to that, obviously we don't want to have that in there. That's why we need to add in more steps, because this isn't bulletproof right now. And I'm gonna get it to where it's going to be bulletproof. So, and it's really shitty right now too, it's poorly optimized. However, I also don't know how to write programs that well. I'm a pretty beginner at this shit. Anyway, so I left off with this, which does the job for scrambling. The next step I want to do is inject a second hash. So we'll add in a second hash, and we'll call it string hash brown. Yeah. Hi, what is deprogramming? It's just like D language. You know about D lang? Let me open a new browser window. Whoa! Oh shit! Hold on. Pop up the documentation for D. D-lang. Wow! D is a general purpose programming language. There you go. That's all you did know. Pretty cool, huh? Nope. Anyway, we're gonna add in my new hash for my thing that I've been explaining. Cool, it's like C or what? From what I've heard, it's like a lot of languages. It's got a lot of different things that it takes from different languages. But yeah, it's definitely more like C. I don't know how big I want this to be either. Obviously, this doesn't need to be a dynamic string, does it? We could declare that. Why would it need to be? Why did I have it dynamic? Did I have it like dynamic? I don't even know what I did earlier. I actually was surprised when this shit worked yesterday. So we have our first phase of hashing, which is absolutely painful. This is honestly the smallest while loop, but that's just to actually create... when it compiles the scrambled version, it does this shit. I guess what it really depends on is how many times I break it up this next time. Because basically when we do this step, it's gonna break. And then obviously we have to do these steps in background or in reverse. So when we go to do them the second time, it's reversing all of the steps we did the first time. Which is gonna be... I don't even know if I'll be able to figure out how to do that shit. I mean, the fact that I'm even able to make this shit look kind of good. Also, we need random number generators, but I haven't gotten that far in my learning yet, so who knows. We'll do, for this one, we'll do segments of 2. We'll just do like, and then we'll do the same kind of quantity, I guess. I don't know. I don't know what I'm doing. Are there any standard lib for D? I don't know. Like I said, I don't know what I'm doing, man. I'm just a beginner. The fact that this shit even works is crazy. I'm pretty good at generating random numbers, though, so we'll just use what I come up with. And this will be my first set of keys to my car. Yeah, I have no fucking clue what I'm doing. I'm a shitty programmer. Bro, literally every other stream before this was me learning how to program. But, I mean, you always start somewhere with everything, so... It's just... I mean, I guess it's a good thing that I decided to finally learn how to program. To make my own shit. See, eventually I want to make my own game, but we're definitely not there yet. I'm also, bro? Okay. Like, right now, this shit's pretty cool, though. Like, scrambling up... Have I shown you what it does yet? So, like, if I type in anything, I can just scramble this shit up. Whoa. This looks like an actual word. Oh, wait. It's so scrambled. What the fuck? I mean, I guess it does contain all... Well, also, if we screw it up here, when we go to decrypt it and do all those steps in reverse, it might obfuscate some of the words. That's a fear? Oh. So we need to account for spaces and special characters, too. Which need to also be assigned to keys, but that's a later task. Is going to be where it sees a dot, a comma, quotation marks, like anything like that. That way, if somebody's using this for like a general chat, it will automatically obfuscate those using the keys that we come up with. So this is just kind of me thinking outside the box. And obviously, it'd be nice to have random, like a key generator for this, but... Okay, the next one will be O. And then... I think that's enough keys. How many do I have here? And that will be hash brown. So hash brown will be phase 2 of the operation. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll go with 10. We'll add a 10th one. That way it's an even number. Do 9. Odd number. We'll go even for this one, and then odd for the next one. Is that 7? Unsigned int seed. That's a random gen on C. Oh. Interesting. I mean, obviously we want like a way of generating these different hashes and shit, so if you want to change it out, you don't have to write it in yourself. I mean, obviously, I don't know what I'm gonna end up even using this program for, but I'm just making it because it's a cool little project. Like encryption, decryption, stuff like that's pretty cool. But the other thing we want to do is like I explained earlier, with a bigger statement, the amount of space to hash it in, like you'll end up with phrases that are still visible, and we want to obfuscate that as much as possible. So I think if we compressed it down somehow to make it so that way it's always a 52 character statement, we compress all of the data into a 52 character statement. Like that way, anything that exceeds that or is less than that will always be obfuscated the same. I think that's a great way of doing it, but I don't know how to do that. So, That will just be my suggestion for somebody else trying to do this same shit. Because I don't think I'm going to be able to figure that out in one episode. It'll probably be a month before I come up with how to do that shit. Fish, what is Matrix? The one you sent in Discord? Oh. You can look up how base 64 works? Yeah, but I feel like that's way too advanced for my skill level right now. I'm still a super beginner. Fish, what is... So, you're asking me what Matrix is, or are you asking for the link to the Matrix? Matrix is this. Wow! Cool, guys! There's only 4 members here, so... I'll also get the room link. Oh, wait. Oh, wow. Yeah, it's basically a better Discord. Yeah. That's why I'm trying to push for all of you guys to use it. Since Discord's kind of scummy, I'm gonna be honest. Discord is bad. Discord's the shitty! I'm gonna say that. Nobody can do anything about it. Who can stop me? Anyway, back to the scheduled programming. So after we finish this step, this while loop then completes. And then we can set... Oh. I mean, hang on. Okay, yeah, that'll be fine. It will go one time and complete. Then boom, right line finished. And then we have to reset our variables, which I do over and over again. I wish there was a way I could just make that simpler. It doesn't matter. So we're gonna need to cut it up this time, and we'll need to divide by 9. What distro am I using? Kubuntu? Or actually, that's wrong. I'm using Fedora. Yeah, I'm using Fedora. Guys, I've become a good person. I now use Fedora. I use Fedora, guys. I'm a Fedora guy. Kubuntu was bad. Kubuntu fried my system, bro. Kubuntu, absolute dog shit. I'm telling you guys. I'm gonna tell you guys something unless I believe it. But that doesn't mean listen to me about everything. All right, let's go ahead and assign B2 should now become B0. Damn, internet started lagging. Maybe. Equals B2 equals 0 semicolon. Reassign that, or actually remove that. That's not an assignment. That's a compare or like a statement comparing it. There we go. Now it's assigned 0. Then we need to assign s.length. Just do that shit, and then equals 0. Whoa. Whoa. And then m.length equals 0. And then we need to assign a.length. Actually, hold on to that. We're going to assign, in the initial statement, it's assign s to a.dupe. So instead, we're going to do s equals a.dupe. Since a is always my final output, we'll take a duplicate of a and put it into s. And then, as you can see, semicolon after that, m.length 0 and a.length 0. Because that resets anything. So if you put a.length, the length property of the array will always be 0. And since working with a string is working with an array, then of course, always. Which is just how I do it. Control S. Water. I need water. All right, and then the next step after we take our lengths and assign those 0 and assign s to a.dupe, which will always clear out s, whatever s might have been. We also have z and pindx now, which is, I call it pindex. It's like index, but better. We also need to add in another scrambling seed and another salt, because I like salt. And we're also going to need to add in a dictionary for what keys to assign to different types. Which all of this will be painful to decrypt. Unless you know how to do it. Oh, I repaired internet? That's cool. So, okay. And then after we do this hash step, we're going to scramble it again. And the scramble, I want to take sections of 2 and scramble that. And then we could also try... Would we want to compress it after? We'd want to compress it in the middle and then hash it again. No. Compress in the middle, scramble, and then they'll make it fun. We'd want to compress it in the first step. It wouldn't be hard to implement compression later. To implement like a base 64 compression, like you said, it wouldn't be that hard to do later on. To implement that before all this shit. Because we don't really want to do it in the middle of all of this shit, but after that, we could do it. We could do it before. So like if I figure out how to do that shit later, like compression and all of that, and come up with a good method to compress it down, that'd be the way to go. I don't know much about that though. I don't, honestly, file compression is like the most important shit. I feel like it's super, for like most people, file compression is not something that is super cool, but it definitely is complicated under the hood. Let's see. After we've done all of this, we can then create another while loop. But we need to take, for this, we're going to inject hash brown before every piece, okay? So we'll have to add hash brown to A, and for this, we're gonna reference the original one, which does all this shit. Kind of a mess, but basically what it says is you take a slice from here to B3, which we need to reset B3 and B1. So we're just gonna do B0 always should stay the same. I don't really want to try changing that, but B1 can change, and then B3 needs to change to 0. I'm pretty sure that's everything I need to change. But we'll figure out how that's going to work in a second, because I might assign B3 is going to be equal B1. That's after we do our initial division step. So we're going to figure out our length for what we're trying to do. And then we're going to take a.length and basically use that to get B1. So B1 is going to be a.length, and then we're going to divide it by the number that goes into by 9, basically. And then B3 will equal B1 initially. So put in B1, and then add in that shit there. So then we can say that B1 is just B3, or no, not B3, it's going to be a.length. Yes, a.length. I believe. It should be, it'll be a.length. And then you divide by, divide it by 2. Or no, 9. Sorry. Now, so that means that once we divide it by 9, that's where we're injecting the hash, the new hash. Also, is that correct? Is that how I do it the first time? Yes, exactly how I do it the first time. Perfect. So now the reason I do it like this is because once we get to the while loop, B3 is going to change every iteration, and it needs to be plus equals B1 every iteration of the loop. B2 is just a clock. So in each of these, B2 just adds up. So while B and then 2 greater than 0, and then of course it's a subtraction, which means what exactly? Well, obviously we have 9 hashes. We could do a less than 9. That way, we don't have to declare it again. So we'll do that. Set up another while loop. And then we're going to put in like debugs and shit. So that way I can kind of see what we're looking at as far as when I go to debug it, there's going to be plenty of errors. For example, I probably fucked up a syntax somewhere and might need to fix it. But anyway, shouldn't be that difficult. Okay. Time to do the next thing. All right. In this part, we're going to take a slice. So M is going to equal a slice. Now, I believe M is an array, a character array. So yeah, that's what it is, a character array. When we do this in the first section, M equals S, and then the slice, clearly. And then a slice of S from B3 minus B1, getting our initial number and then to the next number. However, what if instead I took... actually no. What do we want to do? Put the number in the beginning of it or like in between 2 words, right? So we take... Well, it would already be doing that. I don't know. What if we want to append it to the beginning? So we would do it first. We would add it on first. We'd go in reverse. So we'd start from the end of it and go to the beginning of it. If that makes sense. So that means each slice, we want to invert whatever S is. So we would take A, and we need to find out how to reverse an array, which I've been going through for the book, which is this book here. I like this one. This is the one I've been using to learn this shit, but we'll just use slices and array other features. I'm pretty sure you can actually reverse an array. And of course, this covers the dot dupe and shit like that. And slices. This is slices and arrays. We could also just type in how to, oh, here we go. Slice.reverse 20. Both copying elements and allocating new memory to increase capacity for cost. For that reason, an element can be an expensive operation. Okay. Result. But we want to reverse it. So how does this work? Dot reverse? I'll just type in dlang dot reverse property. The function reverse. The reverse function in D is a versatile utility for inverting order of elements in a range, such as arrays, strings, or iterable types. So you would do that, and it becomes the opposite. Ah, nice. Very good. So we'll take A. Could we just do A dot, what did it say? Actually, hold on. Dot reverse dlang. So the dot reverse function, blah, 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 blah. Oh, standard algorithm. That's not right. You would just use, it would be standard algorithm. Maybe it is a mutation, but I'm pretty sure. Oh yeah, if you just import standard algorithm, you're fine. That's fine, guys. Right line array dot reverse. So instead of taking a dot dupe, could I just take a dot reverse? Or we do s dot reverse. And then we just, we'll do s dot reverse. Right? Wrong. Wait, so is the syntax for this? Okay. A dot reverse. Could I do a reverse dupe? Duplicate reverse? I'm kind of confused. I'm actually kind of lost right now. That's typical though. So we have array, and then you would could you technically reverse that? Interesting. Interesting. Let's see. In where is my thing? Okay, we'll just put in s equals. Wait, so is it? Would it be if I want to assign an array to a reverse of an array? Would that be the same thing though? Why would I be assigning a dot dupe? Okay, here's a question for that. So S is a character and A is a string. A string is an array of characters. So as we see here, character is this. Character is also a U byte. Okay, that's a lot. And a string is a U long, which data types matter because you can't convert between them because of how the machine code works. If you took a byte and tried to make it into a car, or if you took int and tried to make it into a car, things don't align and it doesn't work properly. Okay, that's a thing that will happen in the compiler, is it will be like, oh, you screwed up this line, and this line, because you can't put this into that. It's like trying to plug in a type USB-C into a USB-A or some shit like that. It's like trying to use analog connections in an HDMI. So that doesn't work. If that makes any sense, guys. I hope that makes sense, but that's my shitty way of explaining why the data type kind of matters in this. And of course, if we did array.reverse, so is it possible to, like this is just writing a line. Oh, so you would do dot dupe and then you could add a dot reverse to it. Well, let's do that. Let's see if it gets mad about this shit. Hit Control S on that. And then we're gonna take chunklets of it and then we're not gonna reverse it after this. We're just gonna leave it reversed. Smart. That's how I'm gonna do it. That's my plan. Alright, so we have... And again, it's going to work the same way as pretty much every other segment does. We're going to have a plus B2 to assign iterate B2 each iteration of the loop. That way we can eventually hit that 9 and not just be permanently stuck in a loop until it breaks. The next one would be the joyous B3 equal or plus equal or equals plus, was it? B3 plus equals B1, because B1 is the size that we have to add to it every time. That's the way of remembering that. And then of course this the part of the shit that matters the most is the slice, and every single slice is going to be that. We can just copy that and paste that in there. Basically what this says, the way that this part works, the slice, is the index. This is an index here. This is B3, the value B3 minus 1 to B3. the value b3. And if you subtract b1, let's say b1 is 6, which means each operation we're handling 6 characters inside of the word. So if this is 6 and this is 12, or actually, if this is 6 and this is also 6, then doing this would say this whole statement is 0 to 6 characters. That's the way that works, and we need to have the b3 minus b1. It's the simplest way of doing that shit. Unless somebody else comes up with a better way of doing it, that's how I'm gonna do it. I'm sure there is a better way, probably. Or probably not. I might have found the best way to do it. So that assigns m equals s, a slice of s. So every time it iterates, it will continue to do this. Except it will increase the value of b3. So the next time, it will do b12, which will be b6 because you're subtracting 6 from 12. Now that's just an example, right? Because if we were to have 7 or some other number for b1, of course b3 is also b1 to begin with, it just gets iterated each time, and b1 is a static version of that. So now for the next part, it's actually putting in the hash. So we append on every single instance of what is it? How do we do it in this one? So we append our hash to that, and we'll increase the value of the array for our hash, which in this case is going to be hash brown, and assign the beautiful array b2, since it iterates every single run of the while loop. Boom. So that gives us b2 hash brown, which will correspond to an iteration of the program, and it will go up. So we'll start off with SD, IK, KO, FL, AW, SM, UH, OH, and FT in order. So every iteration it will increase in that specific order, which means that when you reverse the process, it has to go backwards. Should be pretty easy to do. In early versions of the program, I did some weird shit, and I thought I had a way of solving it. I took a bunch of if statements to say if the size is this large, don't allow it to go through. I believe there is a solution that I thought of earlier in the stream, but I can't remember what it was, which I'm just noting that now. And we're also going to have to put in our working batch, which is usually going to be B3. That happens every iteration. Working string. These are debug lines for me. So I'm going to put these in right now. Copy. And then go to here. And this basically works the same way as the original does. It just does it on a basis of 9. Now, we might run into some issues. I believe one of the issues we'll run into is that it's going to end up being a invalid size of the array. So that's something to note. S.length, and then we'll add in another one called S. That happens before we put in anything. You can add a comma and then add in S, which will give us our S, whatever S is, which should hopefully be reversed, right? We want to get a reverse, and then we want to get a regular one of it. So we're looking for the reverse. We'll call this length. So we have length, slength, and length. Wow, such greatness. We're going to take S. We'll call this string. Actually, string is declared at A. We can remove that. We don't need to worry. Our string is printed at A, or written at A. So next up, we have that. We have this. We want to get an idea of what B2 is. So whenever we do that part, the divide part, I always take a value of that as well to put in my debug lines. Also, it's taking M a couple times. So we'll do string, or working string, string hashed, and all of that. This happens at the beginning. So since M is being used twice here, it's getting appended and also being set equal. That's could be an issue. M append hash brown. Oh, well, that's fine actually. Right, for the append hash brown part, we also have a working string. Twice the hash it needs to be. Wow. And next up is to actually make A. So A is my, in the original hashing part, we just do A equals M dot, or A tilde equals M dot dupe to append M dot dupe to A each iteration. A does not change. A is static. And then we write a line for A every single time. That's how it works. And that's going to be the full compiled statement every time we see it iterate. It should just, it'll just work. Like Bethesda, it just work. Okay, and then we do m.dupe. And then, of course, semicolon. And then we'll write out A. We'll call it the hashed string. And then that's a hashing section done. Should work. Because if anything goes wrong, it's going to be... There's actually 4 things that could potentially cause us issues. The first one is that we have invalid syntax somewhere, or some syntax is screwed up, which is an easy fix. Second thing that could go wrong is that we have invalid arrays somewhere. So basically, the array length is too long for like B2. Probably is going to be the thing. Could be an issue. I could check it right now, or we just go into it and say, "Oh, it's fucking broken," which is what I'm gonna do. Then the third thing that could go wrong is that this just needs a couple tweaks to get it to work. Mainly array shit. That's like the big thing that usually happens in these. It could also be that this is invalid too, like I said earlier. I don't know how to use .reverse property. This is my first time using it. Always a first for everything. Wow, I'm surprised it even did that shit. We'll go ahead and encrypt, and then we'll write out a good encryption, good thing for this. We'll type in password is password. Actually, if you put no spaces, it's gonna be highly is a good password. For example, we want to include spaces and a dot just to add that in there, since I want to accommodate those inside of the next parts of my program. It works out pretty good. Now it's even inserting those extra hashes. Of course, once we have this shit, that looks really good. That looks perfect. Each iteration, it's taking... Password is a good password. It scrambles it and then it hashes. Man, this is getting very good. I don't even know what it means anymore, bro. I've inserted D length is 56. Why is the length 56? Some other shit, bro. Who even speaks this fucking language, bro? This is gibberish language. As Zina Gord. Wait, what is that? Gord? Bro. Is that from the previous iteration? Is there actually... What? I'm confused. X. Encryption. We'll do 1. hash browns make a good omelet. Yeah, it's working perfectly. I don't see any, wow, perfect. Divides it by 9 and then inserts more hash. Tella. He Tella! I'm doing great work here. And so the iterations it's doing, it appears to be like current batch is 6, so that means the words it's gonna handle are gonna be 6 long. Zzzpolk. Wow, that's pretty good, isn't it? 12. This is really good. Let's go a little bit further with this. We're getting places with encryption. What if we like compress it in the middle? So the next part is removing spaces. Obviously, if you compress it somehow, I don't think you even have spaces. And then after this is reversing it. How the fuck do you reverse a fucking program like this? No way it's even possible. God damn. We're not even at complex shit and I'm already creating some gibberish machine. I do want to share this though with see, like, let's zoom out a little bit. Bro, that hash. So, I mean, the word length is getting longer. I want to make it shorter, ideally. Obviously, in this section, it displays an array. This array is the actual scrambling array. This allows me to debug whether it's getting injected or not, like if it's actually getting assigned on the array where it's supposed to. So the way that entire process works is I take an int array up here, or actually it's a ulong called pindex. This array contains the new indexes for each segment, which will be word lengths of 6. The way it works is magic, because I couldn't figure out how to make it work until I tweaked it a few times, and it finally compiled and actually did what I wanted. It's kind of just like the God's greatest miracle. Pindex, the Z of Pindex, like, with this, it was hell. Because you can't assign S Pindex, and then, which is what I wanted to do. I wanted to do I wanted to assign I wanted to assign the slice to M Pindex B2 minus 1. Or actually, not even that. Just Pindex of B2. And it wouldn't work. Because you can't do that. Don't even try it. And so we have to do m.dupe, obviously. Because Z Pindex is an array. And because Z has to be a string as well. Okay, Z has to be a string. Because you can't assign M character array to an M char. Or, well, to an S char. Or an A char in this case. You have to convert it to Z. A string Z. And then you can assign it to A. Which was like the world's most goofiest bullshit of all time. Like, that's why data types matter. Now, of course, we have to do the whole reset again. And that is the same as before. So we could either do s.o. That's the real question. Is it working on the reverse? So I did include debugging features. With like D length. And then it includes the reverse. So for D length, let's go up to where D length is. Right here. And then, of course, we have that. We're going to want to include a... Boom. This will give us a space. We could put that there, and then it will look pretty. Okay. Then we'll recompile. So we're gonna type in X to exit, DMD encrypt.d to compile the next encryption, and then 1. And then next up we're gonna hit type up something amazing, right? Walmart is not as good as Tormart. Alright, now it's time to check. Bro, you can't even tell what words those were to begin with. God damn. We are cooking with gasoline here. So, finished, and it has this. This is the string after scrambling. That whole the whole section I covered a few seconds ago before we even get to the second hash is the scrambling phase. But anyway, we have D-link 56, and then we have some bullshit, blah, 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 blah. And then, well, we do our working string. Then we add on SD. And then we have hash string of that plus SD. And then we get to current batch 12. And then subtract 6. Because it's working. Batch is 6 again. Inserts. Keeps going. And gets up to 54. Because the string length was 54 before. And you end up with this. But what we shouldn't have seen happen. What happened here? What happened to the N? Hold on 1 second. Where the hell did the N go? Bro, it lost the N. Okay. So we have to be certain that it's working properly. That's why I have all these debug things in. Obviously, this section works great. This section before D-length is working. So it becomes not zin. Where's Walmart? Bro, where did Walmart go in the original sentence? So we have Walma GG, which gets assigned to the very end. But then where did that go? When it compiles, it doesn't include that? What the fuck? Bro, I'm confused. I'm lost. My whole bullshit here ain't working properly, it looks like. Because I don't see where that goes. And then I'm really confused because this shit loses the N on the end. It looks good, but that's because it's losing shit. Very, very, very... Oh. No. Is it? No, it is. It is definitely losing shit. Alright, so how is it losing shit, guys? We gotta figure that shit. We gotta be detectives and figure out why it's losing shit. So it starts off, not Zin. Not Zin. Oh, God. Bro, this shit's fucking great. Where did Walma GG go? That's the real question. Where did it go? Does it just not get included? Because it should just append each single statement. That's the whole second part of the scrambling phase. So when we go into here, this sequence just compiles A. Just compounds it. It appends Z every iteration. That's how it works. Writes out compiling A. So, here's what happened. It's Z is subtracted to 0. Okay. And we add until Z is the next number. And then, so how this is broken is when we do the next step, it doesn't append everything. It looks like we have 1, 2, 3, 4, 5, 6, 7, 8. 8, which is, of course, this. What happens... B2 is starting at 0. Okay, so B2 here is subtracted down to 0, starts at 0. So every time it should append A of B2, which is at 0, should start off there. We're going to add in another debug here. We're going to call it We're just going to do that, and we're going to add a B. This way I can fucking see what it's doing in real time as it does it. Plus, it looks cool as hell. Bro, you gotta say that this shit's fucking cool. Watching it do its job is the coolest, most satisfying shit of all time. Hey, I think we fixed the problem where it has the extra decrypt in there, bro. The extra encrypt menu keys. Oh, never mind. Anyway, we're just gonna say... Yeah, that's perfect. Alright, let's check. Okay. Whoa. Oh. Look at that. Bro, look at the fucking array for this shit. What is this one? Why is it 81? It doesn't even change. It's just 81. Is that like... What? How is that 81 though? Bro, I've never even looked at B. The B array is weird as fuck. That last one's 81 for some reason. Interesting. We're really concerned with B2 here. Or, this is B... Yeah, it's B2. B2 would be the third one, which goes up each iteration. So B2 corresponds to index 0 of that. Here it's index 1, index 2, index 3, which is getting on to the end, 4, huh? What the fuck? Bro. We're at 0, right? That looks good. Wogs in. Owns, abs. Looks good. And we got this shit. Contantian. And then that is where the problem occurs. Because it's not taking the full word and putting it in there. Or something. Somehow. Oh, wait, no. It's working. Yeah, it was working. Why, that shit. This one. Fucking weird as hell, but it's right there. And we have that. And we have Reading's Clue. We have Enclopsg. We have that shit. And then we have hash brgg. Wait. So where does the other part go? Wait. It has to be working. Okay, I swear to God, bro. This shit has to be working as intended. Like, obviously, that's the salt. Holy fucking shit, bro. The salt's included in the entire... Nah, bro. This shit would be impossible to undo. Unless you have end-to-end bullshit. Bro, it's already impossible, I swear. I might be fucking stupid, though. Oh, okay. So that... What was I selecting? I have, yeah, that one. Oh, hash browns, which is in a... Okay. Makes sense why it looks weird. When it gets to here, it's doing all of the arrays and shit, but... It was just confusing for a second, because it's like, oh, what? This isn't even close to English anymore, and I'm trying to debug non-English, bro. Trying to fucking unbug the English to try to figure out where one part at... Bro, it's fucking word spaghetti. Make me upsetty, guys. Wow. So we have G's in. We'll call that one G's in. That's the reason. Oh. T Walgisen. Oh, nouns. Methurines. Whoa. Perfect. But then the opposite is. And then, of course, checking this section is the fun part. Alright, so we take HGZZZ poll. Higgins a poll. And add SD to it. Higgins a poll. And then 14. Do Knolk S. Knolk sick. And then we have Higgins a poll. Fucking hell. We have Satan language at that point. And then we have Neria. Then we add a KO. Okay. And that explains why it's confusing, but it's doing what I want it to do. It got an SM, got a UH, got an OH, got an FT, which is that the last one? Yes, okay. That also explains where it went in that other one, so I'm not too concerned. Looks pretty good. Next is to take it. We're going to take it, and then we're going to make it even better. We're going to take all of what we just did and scramble it again. Actually, I want to put a salt at the beginning, and I want to replace any dot or like, okay, let me explain. So if I have /encrypt and then I write out like, wow, I like quotation marks pizza, colon, it's good, /xd dot. I don't know. Oh, never mind. I'm doing that in fucking hell. That's why I did that shit. Like if you have quotations for some reason, like imagine that. Quotations, exclamation point, dot, and a comma. What am I going to do with all of those characters? Because they all end up in there. Look, there's now a dot quotations. Like, I think maybe a rule either would be to not have any of that, or to have it replaced. Obviously, it ends up in there and kind of tells you where shit was. For example, if you had just a random quotations there, that needs to be removed. So either we compress it down, everything gets compressed down to a specific subset of characters, or something along those lines. What we could do is assign, oh god, it'd be fucking pain, but we could assign each character its own value, or just use the ASCII ones, potentially, and then you convert those down into like a different base, so it convert it like in, ideally the binary would become compressed by that, but that's beyond me. I don't know how to do that shit yet. Or we create our own dictionary that assigns, well, it still would be noticeable, but would be a lot less harder to track down what each of these characters is, because then you don't have special characters. The idea would be we assign a new thing wherever a special character exists. So we'd want to do like if not, and then we'd assign sequentially, or just have a specific dictionary that swaps those out as it goes through, or remove them all together and obfuscate them. I was going to do that with spaces as well, where you obfuscate all spaces. But then, of course, if we are trying to get out the same statement that we put in when we decrypt it, that's another question. It has to be end-to-end decryptable. So we have to think about that. Like, if I put what I do on the encryption could potentially ruin the decryption somehow. If it doesn't reach that exact word that I want, like if I put in a statement, I want to get that exact same statement out the other side. which is to say that you can't necessarily do that if you obfuscate things. You'll just end up with a sandwich of words. What we could also do, instead of just seeding these, is we put in other things. So imagine this, like decoys, right? The next segment will be a second hash, which will be called the hash decoy, right? So I'm going to copy this one. We're going to put in common words and phrases that are used. They all have to be the same length, obviously, is another issue. Because in each stage, it's, well, actually, it just has to be the same words. Decrypting it's going to be hard because when you take back those words from it, like, then we also have to scramble it again after this with another solve. So we'll call this new phrase decoy. And we'll do, what if we scramble it and inject a hash at the same time? Decoy, which will include special characters, such as the exclamation points and shit. This will be like special characters. Decoy dot. Then also words too, I think, could be a good one to include in this shit. Also, numbers do get handled by this. That's a good question. For me to figure out is, do numbers get included? Yeah. And that's pretty obvious that that's a 1 in quotation marks. I mean, obviously you wouldn't put a 1 in quotation marks, but like, if we wrote in, like, who knows, like, 1976 was a good year for the, quotation marks, Patriots, question mark. Does that come out? What the fuck is this shit? Bro, I thought I had 2 quotation marks. Where'd the other one go? Oh god. Bro, quotation mark casualties here. We're losing quotation marks. Oh? Did the quotation mark get... Where the fuck did the second quotation... Where's the fucking question mark? Bro, I lost my quotation marks and my... That's not something I... That's not something... Good god. Bro. I lost my quotation marks, guys. I never thought I would say it, but I lost my quotation marks. What was it originally? Like... For... Oh, God. What happened is simple. It lost a few... Okay. Okay. Oh, wait, what? Stops here. For the quotation marks. Bro, 1976 was a good year for the quotation mark. Bro. It didn't work for some reason. So it doesn't always work. Ah, fucking hell, bro. Encryptions are from Satan. Ugh. Bro, it just makes you appreciate whoever can engineer this shit. Honestly, it's a lot easier than I thought it was. I thought I'd be racking my head behind this shit for like years. As long as it's handled the same way on the reverse. Could Yiznar fork the ion? 1976 WGGS. A good Yeznar fork Lu the ion. Bro, trying to pronounce this shit. Working string. Oh, it does get there. Patrio hui. And then it doesn't get to the end. So it took slength 40 divides slength by 6 or takes 40, divides it into 6 sections. That's not correct, guys. You can't divide 40 by 6. You literally cannot divide 40 by 6. And then it doesn't even... So, it has to be divisible by 6. Oh! Crap! I realized what the issue is. We have to stop for a second and go back in the code. There's a problem. Okay? See, if hashed string, right? Like if I have 40 characters. When those characters are split up and then hashed, right? As we saw, it will obfuscate anything past that 6. Obviously, if it's way longer than 40, or if it's at 40, 40 is not divisible by 6. So either we need to account for that somehow, and then what? So it only accounts for 36 of the characters, basically. If it's what was it working in? What size words was it? Current batch is 7. Up here, where is it at? 6. It only was able to do divides 40, gets 6 because 36 is the closest thing, which it means that we're pretty much screwed. That means the last 4 characters don't get accounted for. So then it needs to take those and append those on there anyway. Like it needs to have that in there, a failsafe for that. The remainder is what it would be. Because 40 divided by 6 gives a remainder. And that means that the next section, so every iteration, we would need to include some extra, like some way of accounting for that. For the final iteration, it would just be from the end to the last point. So if it's not divisible... Oh, God. Bro. Fucking hell. I hate math. We could include an if statement to catch this, or we could try something else, but s.length right here. So that would be our main thing, is s.length, or slength. We of course have that shit. So would we want to take a index of B3? What we can do... So if S length... so S length will be 6 at this point. By the time we get to here, S length is going to be 6. Ooh. Okay, yeah. I'm looking at the if statement solution to the problem. Because that's the most simple. But we would take an if statement of it. So if... And then, of course... The simplest answer is usually the correct answer. That is the Occam's razors. So when we solve, use Occam's razor. But of course, I would like some advice because this is painful. Obviously, slength to s.length. Then of course, then we'd include an if statement. So if it's that, then add, oh, that's an idea. Append the missing pieces and try again. Right? So if S length is not long enough, we'll just append extra pieces. No, that will make it hard to decrypt. Right? Because then we have to account for getting... Oh, God. No. Let's try to think about decrypting it as well. Since when we need to decrypt it, it's going to be a fucking pain in the ass anyway. Well, we want it to just be doing all of the steps in reverse, right? Then it just relies on keeping those keys between the two users private. Like, no external parties would be able to have either keys. You would need the keys to do it. And if either party has keys, and of course, these keys also need to be obfuscated. So that way, ideally, you'd transmit these with the old keys, and then they'd get decrypted. But that's like thinking in the future. When I go to use this for like creating my own peer-to-peer encryption clients, that'd be pretty interesting. Or something like that. Who knows? Maybe it could be passwords for an operating system. Have your own local keys that only you. You could have randomly generated keys too. That's how you know Matrix is good, bro. Matrix, bro. Yeah, also we wouldn't want to give any indicator. So like what I'm thinking about doing is if it is too short, then append a plus sign for every iteration that it adds something. And then we just are like, oh, okay, we have plus signs. Obviously, we'd want to obfuscate those plus signs somehow, which is not going to work really easily. We'd need to have more keys for that shit. I want to try to minimize adding more keys and shit because we are at this, which that's not even finished yet. So these are basically just different things to create super identifying things, like a hashtag in there, or like add a wow in there. Different things that will different words that are recognizable that kind of throw off anybody trying to decrypt it. Wow isn't that identifiable. It's not super recognizable, but things like hello, the, what, and then any of these like random numbers and shit. 23. Like numbers. Obviously, if it's out of the norm, people are going to notice that. I'm going back to the decoy shit because I really don't have a good answer for how we'd account for if S length is not meeting a standard of 30 or of something divisible by 6. We could append pluses. Do we have a plus in here? No. We could use a key for that, like minus Q or some shit. We'll add a variable up here. That way we could pull this from a config at some point. We'll call it the, what we'll call it? We'll call it like a. We'll declare as a character as a string, since we're mostly working with strings here, and it will be an array, and we'll call it. That's a scope. We'll call it the array, and then we'll call it NLNG. N length. Kind of thing. So no length, or length is too short or some shit. And this will just contain like a couple different variations of plus Q. That way, I can know plus Q means that. That also adds an identifying character, which will be a problem later. But as long as we do the same things in reverse, shit should work perfectly fine. And it will just use, actually it won't even be that. It will just be a plus Q. So that way, whenever you need to change it out in the config, which will eventually be a thing, you just use the config and it will import all this information for you. You can get new configs, and the configs can be encrypted in some kind of super zip file or some shit, or who fucking knows how this would work. This is the world's shittiest technology I'm developing. Honestly, I need to learn more about how to make secret communications. Then we need to be like, okay, well, it's not divisible by 6. Do this. That way we know. Boom. And then if it hits a plus Q. God damn it. Bro, this shit fucking sucks. I hate accounting for the potential that somebody puts in a 40 character long thing. Bro, if you put in something that's not like the and that also includes down at the next layer where it divides by like 8. Divide by 8. So it has to be divisible by 6 in the first part. Then divisible by 8 in the second part. And then we have to work our way down. And obviously, if it doesn't decrypt, so here's the thing, is the more you encrypt it, the more potential there is to lose character. Oh. That's why we should fucking compress shit, bro. God damn. Bro. Compress it from the beginning, remove every problem. Right? I think it's time I go learn about string compression. Good God, what is this fucking... Block elements! Fucking hell, it won't even let me block the element, guys. Time to get Hunix. Hunix browser. What are we typing in? Delaying base 64 encoding. Encryption. Encode. Standard base 64 in the programming language that provides functions for base 64 encoding and decoding. The base 64 encode function converts binary data into base 6. Oh God. Oh God. A base 64 encoded string. So we have standard.base64, which we'll import at the beginning. That's gonna have to happen here. All right, we'll import standard.base 6. Wait, what was it? Base 64. Standard.base64 semicolon. And this also means converting different data types, which is not really easy in D-Lang, because all data types are immutable. And I don't know what that means, but hey, means I can't really do much. And then it will output those. Interesting. A string. Converts the string into a sequence of U-byte 8-bit values. Perfect. Okay. So this just... Okay, so if we used... That's not how that works, right? But it's interesting. What the fuck is this? Interesting. AI is giving me answers to my problems, but I don't really want those. Encoded in ASCII letters. Okay. I mean, obviously ASCII has its values, right? We could just take ASCII values and use those, but... would make it way easier. Way easier to do it. And then... do it in reverse. We do need to... Let's experiment, actually, with base 64 anyway. Obviously, with base 64, you have base 64 encode decode. You type in, like, hello, and then you hit... Oh, we want to encode. Type in, like, hello, and hit enter, and then... Actually, hit backspace and then hit encode. And then you get that, and then what you can do is copy that. Here's what I'm really curious about, is if I can put 2 in there. And then we encode that. And then if we take this, copy it, we decode this. What are the odds we lose data this way? Decode it, gives us that. Okay. And this is just my hypothesis, but will this give me what I'm looking for? Oh, perfect. So it will work. I can encode it twice. In theory. So the reason I would want to encode it twice is if I encode it later. Just in case. Base 64 encode bytes performs base 64. Where's the documentation on this? Library reference. Standard base 64. Interesting. Perfect. Support for the base 64 encoding and decoding. Which also avoids any like extra shit. I mean, we've already got it to where our words are like, so any word you type in becomes pretty much unreadable. And then once we encode, like before, if we encode it beforehand, we also need to determine if there's like a length for base 64, right? Like, is there a standardized base or like length for it? Because we need a standardized length. We can't just have, oh, well, one thing is this long, one thing's that long. Because we don't want to lose data when we add on hashes and lose shit. It's not good. So base 64 again. Base 64 encode decode. All right, yeah, like if we make sandwich for dinner, we encode that. Oh, never mind. Type or paste here A B C D E F G H I J K L M N O P, just to give it something nice and long. And then we encrypt that. Will that be longer? Encode that? Yeah, way longer. Okay, obviously every time it does that, we need to have the same length each time we do this. So if I put in one character, like for example, take the character T, encode that, gives me that. What about D? Does that also, does this encode that? Okay, so it does kind of do some shit. It gives you ZA. Yeah, but like, let's see if hello works. Encode that. Is it the same length every time? We want it to be like basically divisible by something every time. Same number every time. Which is impossible. There's no way of removing that potential that somebody puts in something that's wrong. Like, I can't actually think of it. I can't think of a good answer to the problem. I mean, base 64 would encode it, but can we count on that for if it's going to be? That's not something we can count on. Like, there's no way we could count on that. I don't think we can count on that. I think we're gonna have to just do what I was gonna do before and say if there's a thing here, put this plus the number. Probably is what I will do. Plus a number for how many things we have to fix with that, and then of course we could also obfuscate spaces too. If it has this plus that number of spaces, obviously you can't add a number for the spaces, but for every plus q it has, we should be able to determine that was how many off it was each iteration. Plus q, we'll do plus q plus c, and then yeah, we'll do a string, and then we'll give it a number to an index for that. We'll give it string 4. We'll call this DSP for dead space. Dead space. That's what we'll call it. Equals and then if for the first one it's plus q, and then the next one will be minus z. Wait, plus q. Then go to the next one, comma, quotation marks, minus z. And it will always be, so when we're decoding it, obviously these get reversed depending on where they're at. So keep that in mind. That's if it has beyond what it needs to have for each one. For every space that it has that it needs to be filled with this. Basically, this is to bring it up to the length it needs to have, right? So like a minus q, plus q and a minus z, eventually it will get to the number 30. Once it's equal, divisible by 6, that's what we need to account for. We'll have a minus c. Decrypting this, we'll have to account for which ones are reversed and which ones aren't. But at least we'll be able to tell which ones are reversed and which ones aren't as well. And we'll have a, I guess a dot, no, don't put a dot. Tilde a. That's a good way of remembering what those are. I won't remember what those are, but for DSP, we only have 4. 0, that, which is 1, 2, 3 indexes. And before we even get into these while loops, we're going to have to be like, oh, is S length correct? So that way, I can get it to where we have a length that's divisible by B2. Or, what is it? B3. Or something. It divides modulus 6, right? So if I create another program just to demonstrate how we could do math to solve this, I think you would use modulus, which means that if it's divisible by 6, it will yield 0. Basically, because an int is truncated, we would divide a by 6, or no, s length by 6. If s length, well, here we're trying to solve a dot length, right? That's a shitty way of doing it. We're gonna remove all of this. This is bad. But that does break it as well. B1 equals B1. And then, of course, I'm just trying to figure out what I'm doing here. This is saying that B1, this is the length shit. So if length is that, blah, 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 short string error if it's less, but if else, it's going to be that. And we have an else if here. Good God, this is shitty. A equals X. So if A equals X, B equals 0. Else if A dot length is 0. The nested if statement. Good God, man. Who fucking... It certainly wasn't me. God damn, bro. Oh, fucking hate this shit. Who writes code that looks this bad? This guy. B1 equals A dot length. Divide by 6. B1 is literally just a fucking... That's a safety part. So this was the safety. Oh shit. This was a safety feature. We can probably remove this and be fine. So this is while B0 equals 1. And I think we can just get rid of this. This is a safety. We don't need that anymore, because I'm going to get rid of that. See, obviously that was to prevent if you put in something that's not divisible or not the correct number for getting us a 6. This is an else if statement. We don't need that either. We can remove that. I think we'll be fine with this. If a equals x, and then it sets b to 0, which is always at the first part. Which is at that standard read in. Let's I don't think we're ready to compile this yet, but we'll write line A, then writes line B1. Let's remove that. I don't think we need that anymore. Cool, and then B1 is here. And then it was divide by 6. So we divide B1 by 6. Equals a dot length divide by 6. And then what we do for this is we'll take while and then we'll put a dot length, and then we'll put that in. Oh god, okay, hold on. We're gonna take a dot length divide, or in a modulus of a dot length, right? This is getting weird, but it's going to work. This will be the safety feature. So percent is a modulus, and what that means is it will give you basically a whole number, or it won't give you anything. If it gives you nothing, that means it's accurate. I want to test this because I really am unconfident in my modulus capabilities. Let's go out. Let's go into D tools and create a new one. We'll call this folder modulus testus. That sounds weird. Just modulus. Bro, modulus testus? Bro, what the fuck are we doing? Create new text file. We'll call it modulus.d. And then open a new terminal instance here. Is that new one? Okay, perfect. Cool! Whoa! Whoa! Put that in there. Here's what's gonna happen. Gonna take that shit and do some shit with it, right? So we're gonna import standard D. Wait, is it? Oh, just standard IO. And then of course just continue onwards. And then we have, of course, put a semicolon at the end of that. That's gonna be like if we want to initialize anything, but I'm just gonna do void main, just so I can test out modulus shit. And then we would put in modulus shit. That's parameters for void main, which we don't have any. And then, of course, the shit that goes in my scope is gonna be very simple. Just we're gonna do test modulus of 6 versus numbers that have 6 and don't have 6 to see what returns what. So, of course, we're gonna do write ln, and then we're gonna do percent. Actually, don't do that. Just do 30. We'll do 6% 6, which should just give us the modulus of that. And then we're gonna put a semicolon and then copy and paste this like multiple times. Bro, the fucking hell did it do? I want it like that because that's how it's supposed to look. I'm gonna zoom in on this shit so I can even see it better. Wow. I'm gonna take 6 and 15. A modulus of 15. We're gonna get a nice data set. That way I have an idea. Or 6. We'll put 15 here. We'll put 36 here. And then we'll try out, like, if it's like 40, right? Because that's the one we had problems with before. Is a length of 40 caused an issue? So if we can, if it gives us 0, if the length is divisible by 6, that's what we want. if it's not divisible by 6, so here's my theory is that if it's divisible by 6, it will probably return 6 for this one. Because 6 times 6 is 36, right? But if it was like 6 times 3, it would return like, well, that makes fucking sense, bro. What am I saying? That makes perfect sense. Just shut up. If it makes too much sense, it's fucking wrong. That's not right. It's not supposed to make sense. All right. Okay, we're gonna do the fucking modulus shit. DMD dot modulus or DMD modulus dot D, and then dot slash modulus. And we have found out that if it gives you 0, it's weird. Oh, okay, those are divisible by 6. That's what I want to see. It's divisible by 6, return 0. Thank God. Makes that shit really easy. That will be perfect. So if the modulus of a length, modulus 6, does not return, does not equal 0. So this equal 0. That's the statement we're going to use. We're going to append, or attempt to append, a, and then append, we're going to try to append, what was the variable again? Dead space, DSPS, and then we're going to apply 1. And only 1. Okay, so the way that the idea is, eventually, while this does not equal 0, right? It will continue to add a plus q onto it. That way, there will be like 30 plus q's in there. And we're going to go ahead and control S, and I think this is where I'm going to want to compile everything and try it out. So we're going to hit X to quit. DMD encrypt.d. And here we have our problems. Of course, that is wrong. B1 a.length. Obviously, could read the lines. 95 is wrong. Oh, 34, 33. Those are the ones that are wrong. Okay. And it's that simple ones. 34 is wrong. Semicolon here. Let's see if that fixes everything. What all will that fix? Then we have an unmatched closing brace on a while loop at 105. What the fuck? Okay. Joy. I love when Kate ruins my code. Fuck Kate. Oh god. Kate ruined my code today, guys. First Kubuntu broke. Now KDE Fedora. Kate on KDE Fedora is gonna fucking destroy my code. All right, so we put in this while loop. We have this one. It's the one at 105, which is having a bunch. It's literally every fucking while loop that's after this. Okay. Wow. Just check every fucking while loop in my code until I find where the problem is. Where does this one go? First while loop? Perfect. Where does that one go? Oh, there we go. Void main is excluding them. Why? Wait, what? What? How did this shit happen? Bro, shit happened. Yeah, real shitty, bro. I think we just gotta remove that, and it will work. Void main, where are you ends? Ah, perfect. See, it was just one line of code wrong. Who cares, guys? Who really cares? Not me. Clearly. Alright, and then I think because of that, let's check our formatting on everything. I think it will actually compile now. Wow! that was such a fucking easy fix. I am thankful. Encrypt. Oh god. It just released all of the... Did it just fucking try to encrypt all of its keys? Oh, it tried to run through... Oh, it took the enter key from that, and then it just encrypted nothing. Bro, it actually fucking works to encrypt. Bro, no way. I can encrypt my nothing. What the fuck? How did I get it to encrypt nothing? I actually managed to get it to do that shit? That's crazy. I might be the shittiest programmer ever. At this rate. Stack them energy drinks. Hi, bro. I'm a shitty programmer and I just fucking outshitted the programming. Did it just assign a plus Q for every nothing there was? Until it actually fucking worked? I'm pretty sure that's what happened. It must have just assigned plus Q. Okay, so if I type in something that's like, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 is divisible by 6, I'm pretty sure. 6 times 5, yeah. Okay. 30, 31, 30, we're already at 32, 33, 34, 35, 36, 37, 38, 39, 40. We're just going to end there. I was going to put in the United States, but the odds are I would have gone over the limit of divisible by 6. And it just breaks. Because it can't do that. Why is it broken? Where does it break? Here's the question. So it encrypts nothing. That's great. It apparently has 45, and I'm guessing that's because B3 must be the S length again, which is why it's like 81 and shit. So that's broken. Don't worry about that though. We can fix that. We'll fix it. Yep. And then, of course, it doesn't return to the start. It returns to here, while B, and then does all of that. Does this. Where does it end at? So while that equals 0, then it ends all the way down here. Perfect. And then these are different loops inside there. Okay, and of course, the real question. Why did it fucking generate nothing? Bro, it ran nothing. Why? Why? Why the fuck doesn't it work? Well, that's the question in all programming. Programopolis. Progropolis. I'm the computer programmer. Whoa. What? Programmer. You can't spell programmer without grammar, guys. I'm telling you. Trying to think about how I'm gonna do this shit. Whoa. That's satisfying, bro. There's liquids in them. God damn, what am I doing? I'm getting distracted. Getting lost in the sauce. Alright, so it tries to append this. It doesn't really append anything to A. So what is it appending to A? It's appending plus Q. So it appends DSP1 to the Q. Or to A. But then it doesn't return. Let's go ahead and put a write line for A here. That way I can analyze what's going on in real time. 4K. Recorded in 4K, guys. That's what we're gonna do. We'll call this DSPC. Actually. Oh god! I mean, technically that would work, I'm pretty sure. DSPC. Then put a comma. Let's put put colon 2 space. 2 space! It's like 4 square, but it's instead 2 space. DMD encrypt.d, then /encrypt. We'll go ahead and press 1. And we'll scroll up to where it was running that shit. Because it runs a plus Q every time. So it ran it, and it skips that portion. Even though, here's the thing, so length, right? It's divisible. It's not divisible by 6 in that scenario. So it just runs it straight away every time but it doesn't do it the second time. Obviously, I don't understand. I mean, yeah, it's just adding the pindex to nothing, though. Pindex. Just adding that shit to nothing. That makes a lot of sense that it's able to do that, but it doesn't make sense why it's not... Why it no worky? That's the real question. The real question is why it no worky, bro. Why the fuck doesn't it work? Shit should just work, bro. Same. Look, DSPCA should be perfect, and it should just go into that every single time. Write line A.length. Wait, does it write line A? So A is nothing, right? It takes A, it writes a line of nothing. Where's it at? It doesn't even write a line of nothing. Bro, it skips the whole fucking nothing line just to go into nothing. Just to go into nothing? What the fuck, bro? Uncool. Enter a string to encrypt. So if I typed X right now, does it quit? Stop. Stop. It's waiting for us to put in X. And it needs an else statement. Good God. Hell nah. Ain't nobody wanna put no else statement in that fucking bullshit. Fucking hate else statement, bro. Swear to God. Fucking hell. DMD.encrypt.d. 1. Okay. X to quit. Perfect. It works. It works as expected. Works as expected. Perfect. Work as... Oh, stop it. You can't put letters where numbers go. Work as normal. And... it adds the -z like it's supposed to. Look at this shit. Length becomes 18. Whoa! Whoa! No way, guys. No way. Bro, this is already perfect. So it runs DSPC twice. And for the early phases of this shit, we have DSPC set to 0. Right? There'll be plus Q for the initial statement. Now we have a way of implementing this everywhere. So while A.length is not divisible, we just have to copy and paste this fucking block every time we need a new division. So, Control S. We'll go ahead and scroll on them. A in the pencil. And then, of course, we're going to do, before we even do this, we're going to go ahead and put this in. So we're going to put another while loop. Paste. And then this time, in this while loop, we'll divide it by 8. And while it does not divide by 8, it will just do DSP1. We'll trial this now. Control, save. Hit X, and then we can DMD our shit. And we've solved it really easily. I think we've got a way of solving it. Now, decrypting it is going to be a fucking pain in the ass. But this should fix all the place. See, earlier when we lost the Mart and Walmart or some shit. Or no, it was ton. We lost half of the word ton. Now we can't lose it anymore. This will cover that shit. Now, of course, if it's not divisible by 9, keep adding plus C until it's divisible. But that's going to fuck it up. Because adding 2, it counts as 2 characters every time. So it needs, for the 9 one, it should be a 1 character. Honestly, if we were to do it smart, we need a unique character until it equals the correct thing. But obviously, adding 3 characters, adding 1 character is the best option. So now we have DMD encrypt.d. We're going to do .encrypt. We're going to hit 1. It does this shit, but don't worry, because we're going to add in, we're going to type in our words, all right? Like, Walmart is cool. Oh, shit. Control X. Control C. What happened? What went wrong? We'll try it again. Do DMD encrypt.d and fucking do this shit again. 1. Jolly good day, bruh. Plus Q. What's happening, I believe, is that it's an instance of... Could be an instance where it's adding plus Q every single time, because adding plus Q every single time, it won't ever reach a place where it's divisible by 8 to get to 0. Does not equal 0. Adds plus. Adds a Q. Wait, it's not even hitting that. Let's try it again. DMD encrypt.d /encrypt.d1, and then we'll type it in. We'll type in a 10-word state, or 4 words, right? Actually, yeah, 4 words, right? 4 words should be pretty easy. Like 4 letters, 6 space, enter. Oh. .encrypt. We'll try 6, enter. Control C. It won't be divisible by 6, right? DSP plus Q every single time. What if we just set it back to 1? Can we do it with a 1? DMD.encrypt/d. Okay, we'll do 1, and then we'll do hash brown. Okay, it still does it. It's because the length... Well, the modulus of A6 does not equal that. We could put an if break statement, but I don't think that's going to help us. I'm going to be back in a second. I don't think the modulus statement's going to help us in that case, where we added it if this then break. mean, because obviously with that, somehow either the statement's not ever going to validate, or like something's going on here that's causing it from not actually doing what we want with the expected result, which is obvious. I mean, so it does the while loop, does this whole thing. Is this scope correct? Is this correctly formatted? It appends that to writes line DSP. Does it write the DSP line? Where is the DSP? Oh. Hash brown dash ZZZZZ. Oh fuck, bro. Wait, hash brown dash ZZZ. It just gets stuck in a loop of dash ZZZZ. While a length and then not equals 0. What is a dot length in here? So if a dot length, maybe if we put a test for it, like test if a dot length, we'd nest an if variable in here. If a dot length is good, continue. Jolly good, right? Let's put an if statement and then test. Bro, I fucking hate nesting an if statement and a while loop, but if it's gotta happen, it's gotta happen. Set that back to 0 since plus q isn't causing our issue. I'm assuming it's this while and then if statement that's going to fix it. We're going to put in our if statement that's going to test a dot length again. And if a dot length, copy, paste it. Does actually, let's try something else. Instead of doing that, we'll use a plus symbol. We'll use a plus, a minus, a slash, and a tilde to represent that scenario. Whereas these other things are just decoys. Those will just get shoved in there in case. These will be like actual DSPC is specifically if we are checking like the length of it, for example. See if the length is shorter than it needs to be, we need to add a DSPC in there and just string DSPCs. And then when it goes back to decrypting it, of course, we have to consider reverse steps, DSPC backwards, right? Using our DSP in reverse order. It's like an ambush. It makes sense, right? Everybody know ambush? Everybody know ambush. We'll just do dmd.encrypt /d and then we'll do /encrypt. I believe this will work, right? So if I put in mode 1 and then I go, I like sausage. Super encryptable statement. Yep, it works perfectly. Splendid. And that also counts up how many times it iterates for that loop. To get our DSP to that original length, it has to go 4 times to become divisible by 6. This is the way of solving it. It's just to append a bunch of different symbols until, of course, they'll end up in the main encrypted thing. And obviously you don't like characters like that, because if anybody's snooping and goes, huh, there's a pattern here with these characters, how can I put it back to... It would be impossible for you to put this shit back together as is. But if you're smart and you like reverse engineering shit, well, maybe you could probably reverse engineer it. That's the question, though, is like reverse engineering. How do you account for that? What kind of plan do we have? And then it appends these to the beginning. And then when I do my next shit, which is going to be... We're going to also include a feature for the next section also, by the way. So we're going to take that whole statement we did with the DSP 0, because that's the most accurate one. Copy it. We're going to paste that in for my next A length. So we have A length 8, which is covered by this DSP 1. And then we need to add another DSP for length of 7. Or length 9. Yeah, here we go. So right after this B2 equals 0. Actually, yes. We'll put in this shit. Paste it in. My while A dot length %6. Exclamation mark equals 0. Then do that. We're going to put 9. So that way it's a modulus of 9. So if it's not divisible by 9, it will append numbers. Or append the shit. Hit X, dmd.encrypt/d. Oh. Oh god. That's bad. /encrypt. 1. It should work. And then we can what did it encrypt? Oh, wait, was it not 0 is not divisible by 6, right? Error. Bro, where did it get the plus from? That makes no sense. Who knows? Alright guys, time to encrypt some shit. Jolly good day in it, bruv. Encrypted. Just a triple, double, wait. It doesn't even reach the step where it rearranges it, does it? Oh, it does. It includes a slash there. Where's the slash in the final product? The final product! Current batch is 7, so it reached a point where it was divisible by its length 63, which is 9 times 7. And then... why is there just a length of these here? I mean, I guess that's because it wouldn't have reached the point. Yeah, it would if it just has... who knows, guys? Who knows? Wow, jolly BXK day. Jolly GGG good BXK day. Zen in it. Labrov. What the fucking hell? Oh, did it have a slash at the end of my state? No, fucking hell, that's where the slash comes from. Where the fuck did this slash come from, bitch? We're getting there. Okay. Now, it's appending a DSP0. It needs to be appending the DSP2. DSPC2. Control S. X. DMD. DMD.encrypt.d. DMD players, when they realize D language is called DMD, bro, they'd be playing DMD all day. Compiling every day. 1. Enter. And it just works as how it do. Wow. Okay. I mean, of course, here's the thing. If you know that this is appended every time, then you can count up and be like, well, but then what does it even mean? What was the original statement even? It still keeps anonymity of the original statement, because as long as there is no numbers or special characters in the original statement, I mean, obviously it's covered by my insert random characters, but that's not going to be until the end step. That's not actually something we can do. Well, no, hold on. If you have a seed, you can get the same random number generation every single time. Interesting, but both people need the same seed to decode it. And we want to not have that kind of surface area. So if we were to randomly insert like decoy things, we're just going to have to do it based on a regular instance. We'll take the number, or we'll take up the word, we'll divide it by the amount of different ones we're going to insert, and then we'll insert those in order in another hash. So we're just going to create another hashing section. So after this while loop, we'll do our next one of these. Right? So we have another DSPC for 3. DSPC 3 is a tilde. That's going to be the last one. So we'll just copy this shit. Paste it right here. Paste it right here. Boom. And then do another DSP, or copy this shit too. Instead of inserting hash brown in there, we're going to just insert the other things. And of course, to make this work correctly, all of them need to be the same length. So go through and make them all the same length. If they're gonna all be 5, it's gotta all be 5 to begin with. Oh, that would be terrible though. Oh god. But if we added in like an extra shit in there. Yeah, that's good. That will really fool the system. That's 5. That's 4. Let's add a and. Yeah. That will really fool the system in that one. And put regularly looking words in there. Go hashtag sh. Hashtag gosh. Bro, I like that shit. Put that in there, bro. Put a dot. That will really be confusing. And then after that, scramble the shit. Exclamation point. What if we put... Oh, I got a good one. Bomb, exclamation point. That's one you want to include in there. That way, whoever's decrypting, it's like, oh, wow, we really figured out what it's about. And make the most impossible decrypt thing to decrypt ever. Truly the most amazing data ever. Ah, we've really figured it out. We've really cracked the code, but we're almost there. And it's literally just the first layer of the encryption. It's like an onion. It's got like 5 layers. The next layer after that's the decoy layer. And then the hash brown layer where it's 2s. And then the hash layer where it's 3s. The multi-hash. Hash god. Hashtag hash. Put spam dot. Okay, maybe not. Good. So that's 5, because good is 4, plus a period is 5. 1,020. That's 10,023. I mean, it is 5. It is 5 characters. Okay, there we go. And that will throw anybody off who looks at the second layer and gets through it. And then we'll put on our final encryption. We'll do a 2-stage scrambling, which will be fun to program in there. So, good God. It's like 1,000 lines of code for this process. Hey, at least it's not like a fucking shitty command line game. Good God, this is way better than those. See, back in my day, used to program all those shits. Now I'm here programming an encryption for some fucking reason. Questionmark.com. Bro, questionmark.com. And then hash brown. And then, let's see, what am I doing next? Encrypt shit. We need DSPC3, which will go after this shit. Wait, that's DSP2. And that means, okay, so this next line covers DSP3. We need our length that we're going to want to divide it by. So, for example, if I split it into segments of, like, for example, let's go with a reasonable number and say, I want to put it, I divide it by the amount that I'm adding every time. So, like, for example, if I was going to do it twice as many times, like, what if I want, well, if we put multiple instances of that, we don't want that. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We could add in more of these just to really throw it off, but Decrypting that part is the hard part because we know what these look like, right? Removing this out of there, like obfuscating these pieces, it's gonna be hard. Especially after we scramble it 2 times. The unscrambling is the hard part, but that's something we can code once I get back. Good God. I mean, we could add, technically you could have up to 18. What if we doubled the numbers and have 18 different instances? I don't really want it to divide by 18. I think we want to keep it like as low as possible. Let's do, because by that point it should be close to divisible by 9 anyway. I mean, after that last round it was divisible by 9, but if it's not divisible by 9 in this case, and we'll leave in white spaces as part of the fun as I'm gonna call it. Yeah, I think we'll just keep it as 9. I think that's a great way to do it. So we have 5 2s, 3s, and at 3s you have 8. Right? That's 8. Pretty sure that is 8 different keys. 2s you have 9, 3 and 5s you have 9. The 5s are whole words. The 2s are just 2 letters, usually an uppercase, a lowercase, some combination of that. And then this one is a combination of the same of 3 letters, can be any combination of uppercase and lowercase and any letters. So that will make it easy to determine what layer we're on. So in the first layer, removing the first hash, right? There's, with that, you have to be like, to consider what the hash even is, right? Like, you can be like, oh, well, I have this. Both parties have the same keys. So if one party has this key, one party has this key, like if they have all the same keys in the correct order, it will make it way easier to determine. Now here's the thing though. Obviously with keys, it's about transferring those without the keys even being discovered either, too. So both parties have to have the same keys, but the keys can't be just plainly visible, being transmitted over like the air and shit like that. Which is interesting to me. But that's hypothetically if this was to become like a mainstream method, which it definitely isn't. So we're gonna inject the, what is it called? Decoy of B2 in there. Decoy of B2, and then everything should just fucking work. So append decoy B2. Well, and is it just decoy or like actually just decoy? Oh, it's just capital decoy. The decoy hash is the best hash, and then we're gonna control S, hit X, dmd encrypt.d/encrypt, hit 1. Look, it even includes it. Nice. Hello, Gordon. It's time to choose. Whoa. Bro, it fucking... String hashed. Dasa.com. Bro. Questionmark.com. It works. It totally works, guys. Whoa. We do want the second one to be different, though. Huh. I could add more. Make it 10. We do want to avoid these special characters, though. That way we don't have to worry about decrypting them. If it's 9 the first time, the second time is also going to be 9. Or divisible by 9. Okay. This is really good so far. Bam! Hostias are good. 1023. And then if we could do random numbers for this with a seed, like instead of these, that would make it way harder to decrypt. But I'm a simple man and I just want to make my encryption 2.d. So we're just going to do encryption 2.d. The first release of encryption.d. Wow. Can't wait for the first release of encryption.d on my matrix. It will be a free and closed source project. I only have the end source. Wow. Wow. So yeah, instead of that, let's do 18 for the next one. If it's divisible by 18, it should be divisible by the same shit. Let's try 18 for the decoy. Divisible by 18? Yes, perfect. If it's not divisible by 18, which is twice the amount of 9, try that. X. DMD, okay, and then /encrypt. And then 1, and then, oh no! Oh god! Index P. Index 9 is out of array length for 9. What the fuck? Bro. 8 out length. Okay. Oh. Right. Yeah, that means we'd have to add in a couple more. We could just, yeah, we could just copy and paste these. Copy, paste it in there. I want to have 18, I think. That's a great number. It's 4, 5. Okay, and then for this one we'll do that way. Look, could do a number like, yeah, like a phone number, bro. Throw in a phone number like 756 is a phone number. Pretty sure. A Georgia number, probably like a East Coast number. 23 ASH. Yo, I just finally made an analog of make. What's make even? I don't even know what make is. Man, I'm surprised you're still watching after this long. I've literally been just talking about the program that we're making for 2 hours straight now, almost. It's a pretty good program, right? Let's put in 58-03633. Yeah. That's not gonna work. We could put -0363, which would work. Like as a podcast? Yeah, that's cool. Some people do that. We're putting in different decoy words. It's a perfect idea. Decoy words. Do I have a GitHub account? No. I actually might have one. I actually might have one, and I don't even know what's in it. I don't remember what's in it. But it's been so long since I used it. I just write code for fun. Or just to learn it. I don't know. This is pretty cool though. When I make fish tech, I'll definitely include that. Fish tech will be my game. It's gonna be like Minecraft, but full open source, free to play, and then I want to have mods as a thing in it. It's gonna be great. I want it to be mod focused, so the players make the game. Like, yeah, the game's gonna be like I'm gonna do some development, but I want I want the players to make the game, like the mods and shit. We need some names of cities. Cool, on D-Lang also? Yes. Yeah, I want to program it in D-Lang since it's easy for me to learn as well. Since I've been finding this easy to learn. Java is probably the best for modding, but I don't like Java. I feel like, I don't know. Java's spaghetti code. At least it's hard to learn for me. Maybe I could get started with Java, but I feel like it's just like fucking cursed. I hate fucking Java. I'm never gonna be a Java programmer. We'll do .NET for this one. We'll do H.NET and make sure to include like these phrases in here. I'm straight C and sometimes assembly. ASM. Is ASM assembly? I don't know. Bro, you must be a madman to program in assembly. Assembly. Oh, God. I haven't even seen assembly. How do you even do that anyway? How do you compile assembly as well? I've just heard it's fucking terrible. Heard it's absolutely painful. That only the best of the best can program in assembly. Yeah, okay. We'll put in HTTPS, which will make it look super legit. Want to check my GitHub? You could post it if you want. I don't know if I'll check it right now. We'll put ://ww. And hopefully that doesn't end up being some weird escape sequence, but I think it won't be. We'll hit Control S, so that way we have some good combinations of words, phone numbers, and then websites, so it looks like some kind of a conversation that would be interesting to read about. Now, when I do my dmd.encrypt.b, like its website, yeah. That way when you go through it, you'll be like, oh wow, I'm getting close. And then it's just not. That's like the first level. So it's going to be hashed with things that look like they'd actually be used in a web page. Or like some kind of a conversation. And then of course, it just prints out the basic encryption of nothing. So it encrypts nothing. I have no idea how that works. And then oh, it's like it actually prints out a fucking website. Oops, I didn't mean for that to exist. Click on it. Can I open the link? Open link. Or maybe I could even put localhost in there, bro. Could put localhost. Put localhost and it's just a virus, bro. Interesting protocol. Yeah. It makes it look like a conversation. So it looks like some of the words are kind of decoded. So if I put in Elon Musk coin is a great shit coin. And then it does that. And it creates... It always puts .com at the end for some reason. Oh, it put .com twice. It has www. What the fuck is this shit? sh.net https DSAH. to fuck his bomb. Bro, it fucking makes up websites. But does it really work? Well, I mean, 9 is 90 divisible by the number we're looking for, right? Also, what is the DSCP that we've put in for here? DSCP3, which should give us, well, 0, 1, 2, 3. Okay. Is it putting in a DSP3? Because it goes up, so, okay, 72 for D length. That's before, let's go from the start, though. Let me zoom out. Just so I can see the whole thing. So here, in the first section, we have the DSCP, or it registers DSCP. And it's like, oh shit, it's not divisible by 6. So it's not divisible by 6, it adds 2 pluses. So it gets us to S-length 36. Then current batch splits it up and adds in the hash, the initial hash. Perfect. 18, 24, 30, 36. Then coin plus plus, and then plus plus hui. And then continues on. And that it still looks like English at this point, but here's where the salt's injected. We add a salt right on the end. See, if you want to do a salt better, you'd split it up and salt it, but we've already hashed it, so like the hash is basically almost the same, but we put in a hash in the middle, which is terrifying. And then we do that twice. So the next time, we have to do this shit, which recreates takes out the words, puts them in an array, and then we'll rebuild it after scrambling it. So that's basically, this is the scrambling step. So at that point, it becomes no longer English, and it's a scrambled mess. But before it can do that, it has to do another batch of DSPC. So the DSPC, which is adding a subtraction to it until we have that. And then we're on the end steps. So then after that, reaches this, and it's like, oh shit, it's not divisible by 18. Oh. If it's not divisible by 18, it has to do the same shit again. And then it's adding in different phrases and shit that look like a good sentence. Looks like different combinations of words and phrases that you'd throw in there to throw off anybody trying to decode it. So then after that, we'll then scramble it 2 more times in different batches. Of course, when we do these, we don't need to have it, it's already divisible by 18. Let's just keep doing divisible by 18 will also be divisible by 9. And would in theory be divisible by... No, let's just say divisible by 9. 9 for the first one, and then of course we don't want to add another DSPC loop in there. So any other factors of 9. 9's a prime number though. 9's a prime number for sure. You know what I mean? 3. 3 would also be divisible. Technically we could just do 3 to start off, but you'd want to go big number, small number, I think. And that will be the next scrambling phase. The scrambling! And the scrambling protocol was... Oh, the scrambling method was pretty easy. We just have to reset a bunch of shit for Pindex. We'll have a new Pindex, actually. We'll have PINDC. And it will have to be 3 numbers. So we'll have to have 2 more of these. Of course, we're going to change these slightly. So we have Pindex. I guess I can have fundex. Or funds. Fundex. And express x. Sounds great. I like the naming conventions already. These are gonna be U-long. I don't know why I was doing U-long. We'll just ask questions later, but we'll have 9 and we'll have another one for 3s. Hold on though. Divisible by 3. 30. Right? I think we need to do more testing on different sentences. Like, for example, bread is good for communists. Or something like that. And then it ends up with 90. Jolly good. 72. It's divisible by 9 again. Hell no. 72. Yo, should I continue making an OS compiler? I don't know what to do right now. Honestly, an OS compiler sounds cool. I don't know what that really would do. I'm not a super great programmer, but that's pretty cool. Spider-Man uses Linux Mint. Gives us 90. So what length gives me 72 90? No, I said an OS or a compiler. What, 1 or 2? Bro, make them both at the same time. Make an OS compiler. OS or a compiler. I'd say OS. Bro, an operating system is like the ultimate game. Ultimate challenge. If you can make your own from like absolute scraps, you must be like a madman. Include GPU parallelization. If you think you can do it, do it. Just do it. Okay, so we're getting like 90, and then Springus. Springus? Already have both? Oh. Honestly, wow. That's crazy. You've made your own OS and your own compiler. Maybe you should make your own language then. Or like... That's 72. R would be 72. Anything less than compiler is a language? Oh. Well... My own syntax in compiler. That's cool. Man, I wonder if there's a Python compiler. Oh wait, is that a dumb... I don't know anything about Python, man. I think Python runs in just a fucking... There has to be already. Make like a Java compiler, bro. HTML compiler, bro. HTML compiler would be crazy. Make everything like HTML. Make a cursed programming language. Damn, Python compiler, bro. Dead roses. HTML. HTML compiler, man. Straight up, compile that shit. I'm gonna be programming, instead of D, I'll make fish tech in HTML code. Bro, HTML isn't even a coding language. It's a formatting language. But HTML is also super easy. So for the most part, everything's 72 or 90. Which means I'm gonna have to get out my handy dandy calculator. Don't worry, guys. I got this. I'm gonna put it into my handy dandy calculator. And I'm going to see if I can divide both 72 by 3 and 90 by 3. Until I can get them into their most simplest parts. 24. Yeah, I know it's a interpreter. But what if you compiled it? What if you compile Python? Right? Like, make a compiler for Python. So that way it's not slow as fuck. I mean, because it doesn't Python go into like C and then it gets read by the machine? So like the actual interpreter is written in like C and then compile with I mean, that'd be cool. Wait, compile with Python? Compiler for Python. HTML though, bro. Well, it already is in C. Yeah, I thought there was some relationship. So, what is something common between 72, I guess 6? 72 divided by 6. Wow. 12. 90 should also be divisible by 6. 15. Okay. Cool. Those will give me my lengths. So I'm going to use a 6 and a 6 for one, and I'm going to use for the other probably, like, I could do 90. But then I'd have to have 90 individuals. Bro, I'd have to come. Okay. Well, time to create our scramblers. We're just going to... So for one, it's going to be that, and then for the other, it's going to be 6. So 9 and 6 are going to be the two numbers. This one will take words of 10. This other one will take... Yeah, it will make sense. But we're going to reassign them into these arrays. So we'll take one... well, for starters, we'll just make it really easy on me. All right, let's go ahead and get this started. So we have... These also have to be indexes that correspond to the values. So the highest we can do is 1 less than 9. So we'll do 8. Then we can do, from 8, we could go to 1. And then from 1, we can go to 4. I don't like that. That's too similar to the first one. Let's do 1, comma 8, or yes, 1, comma 7, comma 4, comma 5, comma 6, comma 2, and then add a 0 at the end. Because that should be the correct number. But should be and is are not the same thing. Oh, right. And it also can be a number larger than this. So while this is 8, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then we need this one to be 9. Wait, what? Oh, what? 0, 1, 2. I don't have 3, and I need 8. 3, comma 8. This shit's painful. I swear. This could get really confusing. Alright, then we'll have to have the first one. It's going to be 5, comma 1, comma 2, comma... I actually avoid 1 and 2. Just go with like a nice 0 in there, and then a 4, and then 2, 3, 2. That is 1 through 6. That's how we're going to do that one. Then we're going to assign our different values. Or actually, where is it at? Here we go! The Machinetron. We're just going to copy and paste this whole block so I can hurry this shit up. Rush right through it, guys. When in doubt, rush it out. We'll take this, we'll have a clength and plankth. Those will be the new names for z-length. So now we have slength, delength, clength, plankth, which are just funny names in there, like ass, right line ass, short for assembling, combining. It makes it sound cool, but it really isn't. It's really just basic shit. putting strings together. I mean, this is ultimately just a game of strings. A game of stringing shit. Then we'll have to double check and make sure everything's good. Clength. And then plength. And then for these, they have rules that we have to apply. This is massive, bro. I have really written something massive. Truly amazing. Check that we've reset them as well. Oh, right. Did I even include the actual part where S length, and then we get to Z length? Where's that at? Z length! Wow! Totally cool! Copy. Go down to plength. What was it? Fundex, and then ExpressDex. Or ExpressX. Plength. Before plength comes this shit. Oh, fucking hell. Put it in there. What? No. Where's my other shit that I meant to copy and paste the first fucking time? Plank right here. Straight up, plank on top. Planks! The first one was 9. Next one is 6, I believe. Clength has to be 6. And of course, I believe is a terrible answer for this shit. Should just know the answer. Shouldn't be an I believe statement. I believe the answers! No, wrong answer in any situation. Should always be, I know the answer. I know the answer or I don't know the answer. It's either one of those two. Also, that's not Pindex anymore. That's going to be... Let's see, Fundex. Fundex ExpressX. So the one that's this one... Where is it at? That's going to become ExpressX, but the other one's going to be Fundex. Fundex. It's like Windex, but fun. And we'll even include those for me. Eventually, we can also remove all of these lines for like the final release. Final release version. If it works, if it compiles even. You know, odds are this shit won't compile and I'll be a super sad guy. XPRX. Bro, I wouldn't fuck that up. Because it's not XPeedX. SpeedX. Whoa. Then that should work. As long as everything gets reset properly. And everything works out. Whoa. Cool. 6. Actually, you'd do 7. What did you do? 6? Yeah, it would be 6. Control S. And while it's less than 7, well, it's greater than 7, and then this one has to be 9. Control S is less than 9, and then less than 6. I probably fucked up something, but it will work. Kind of. X DMD encrypt d./encrypt 1. Perfect. It's already caught the errors. Current operation 9. Fundex 8. Okay, so it got down there and then created our gibberish like it should have done. Oh, I love my gibberish every day. Index 8 is out of bounds for an array length of 8, which makes sense because it's using fundex on its current operation was 9 and its fundex is at 8. Now, if its array length that it's trying to assign is 8, So that means we've gone over. So that means in here, because I've tried to cut corners, I've caused some issues. Oh god. Yeah, somewhere in here it's doing some fun shit, like right here. Index 8. Maybe this is the problem. I could be wrong, but I think I just need to shorten these down by like one number. And then it will just work. Todd Howard, it just works, guys. Just works, Todd Howard. Perfect. Wow. Let's see if that actually does it. And then hit 1. No, that doesn't do it. Oh, actually? Does it, just, yeah. Index 8 is out of array length for... Array length of 8! Oh, what? Maybe I was wrong. Did it assign everything? Oh, it did assign everything. Well, it went through and assigned everything into the initial variable, or initial statement array thingy. So fundex 3. Why is it already... Oh, wait. Does it clear out the original S variable for that? Hold on. So before the length, or Z length, right here, Z length, S equals A dot dupe M dot, okay. Wait. A length. A dot length. Also, it will tell me where it's at. So D144 index 8 is out of array length of 8. So if we go down to 144. What? Oh. Wait a second. Oh. Wow, hold on. That's gotta be 8. I think. We just missed this. That was it. That was all that we had to do. Alright, let's go ahead and dmd encrypt.d /encrypt.d. And then just run, hit 1. I mean, it kind of did something. God, debugging this shit, bro. Fucking Satan spawn in this shit. Fucking hell. Look how many lines it makes now. This is why maybe I should do it block by block instead of having it do it all. I mean, it does the encrypting stuff. Does it so in compiling step. Okay, so in... Oh. Wait a second. What is used for, I want to see these empty. That's what I want to see. So that way I can keep track of what has shit and what doesn't. That would be great for my soul. It's not necessary, but it is great for my soul. I'm pretty sure string is 8. We're going to make that dynamic. Oh, fuck. I hate that. But yeah, we're going to make that a dynamic string. And then that's going to just work. We're going to go down to Z length. Right before we hit Z length. Z length. Right here, Z length. And before we hit Z length, we're going to hit Z dot length equals not 0, it's going to equal 8, and then we're going to put a semicolon. And then after it does all that shit, we're going to make Z dot length equals nothing. Right? So we'll hit Z dot length equals 0. And that should cure my pain. So then when we get to that final step, we have to assign a Z dot length to 9. Equals 9. Semicolon, save. Go down past this one. equals 0. And then assign z.length equals 6. And then it's done. That's all the z lengths you need to do. Right? Because that is painful to look at. X 1. Okay. Fucked up. I fucked up whole kernel on my OS. Damn. Man, I wouldn't even know where to begin writing an operating system. Alright. And it's not doing... Oh. Wow. It's skipping a few here and there. I'm guessing it's missing 1 each time. And that means that it wasn't these, but it was actually probably the other shit. 6. We'll try setting these back to 6 again and see if that fucks this shit up, but it shouldn't. We'll see if this works or not. Next quit dmd. Okay, ./encrypt.d1, and then no errors. And it looks like it assigned everything in there. And then, so what it does, when it compiles all of this shit, should take 6. So length is 22. Why is length 22, bro? What we're dividing by 6, it should be like a lot less. What's the whole total length of the fucking string at this point? I mean, it does create something that's not a thing, I guess. I mean, we just want to check that it's taking... Okay, so it takes that, puts it at the end. But it's taking... How big is this one? Length is 15. Bro, I fucking hate that it's 15. But I don't want to assign like 23,000 different ones. If that makes sense. I mean, I could divide by 30. Can I divide 72 by 15? That's actually a good question. 4.8. I can't do that. 72 divided by 6 is about as close as we can get to anything. Oh, 72 divided by 12. Can do that one. Is that 90 divides by 12 too? No, it gives a float. Okay. Yeah, so we're at the peak of performance right here. Gordon, we have reached the peak of performance. And wow. Bro, shit's good. It works. Works as intended. Whoa. Now make it work with less than 140 lines of code. Here's the DSPC portion. Assign DSPC over and over again. Bro, you can't even tell me what this says at the beginning. at, bro, it just makes shit up too. Compiling. I'm gonna copy this and paste it in my Discord. Bro, what do people think of this? Gordon, we're doomed! Gordon, we are encrypted. Arced? Ached? Bro, it even made up the word ached, bro. Fucking hell. Gordon, we are encrypted. I just like how it includes that. And then, let's see. Word spaghetti, right? This is like shitty transforming words. Shitty Google Translate. Gordon, we have reached peak performance. Equals. Copy. This. Truly amazing. Wow. This is impeccable. Well, we haven't gotten that far yet. I haven't written a decryption for it, but we've made a hell of an encryption. So, really what I want to do is clean this up so it's not so disgusting, but let's just give it a few shots and see what it can do. The numbers we expect to get on the last set are going to be 90 or 72. So, of course, it throws in different, like here, it's creating this. To actually decrypt it, we're going to have to start by doing the inverse. So in while 2, we would do the opposite of the original. Or, well, the opposite steps. So we'd start by going backwards through our steps. I mean, I don't really want to do it today. I feel like I've done way too much programming today. The fact that I've even gotten it to just print out this shit. The fucking line of slop here. Bro, this line of slop is amazing. But we'd want to do it in reverse. Step by step. So we would take our original... I mean, I think you could do it backwards. It wouldn't be hard. Oh, God. Doing it backwards, bro, it's fucking painful as is. I mean, I could just sit here and just say how painful it is all day and just not do anything. It's gonna be painful. Alright, time to write the decryption. Oh, God. Well, I mean, this one's only 4 steps. What the fuck? It only does this part. Does it 6 times. That's perfect. So we do the opposite 6 steps, right? So if the key to encrypt it was... So we do xprex first. We do exprx first. Then we need to do, for the other part of the decryption is fundex. That'll be second. That will get us back to a pre-fundex state. Which is, then after that comes the decoy. We'll need to remove the decoy. I mean, it's basically like the Enigma machine, but like 30 extra times harder and more complicated. The code is impossible to crack. God damn. Alright, let's just enter. And we'll do a... we need to do a while loop. We'll do a B2... We'll sign B2 equals... And then we'll make it 0. No. We'll do it 6. So that way it will start on the 6th index. And then to decrypt for that, we'll do a while. Since we already have it encrypted, it will already have all of the keys too. So we should be able to unscramble the slices, because it's just chunks of words basically put together. Which means that as long as you know what the sizing and shit of the words is. So it's not... If it was configurable, that'd be better, because then you could just switch it out anytime you need it schizophrenic and think that people have cracked the code. Or some shit like that. Who knows? Paranoia. 6. while 6 is greater than 0. Or while B6 will, greater than 0 would always be true. It'd be unconditional. Well, B2 greater than 0. B2.0. Float! I hate floats. I mean, they have their usages. Scope. And then inside of my scope, it's time to choose. Def. No. I choose encrypt. Decrypt. D-lang crypt. And then we need to undo all of the shit. And then minus 6. Minus B, and then 2. Semicolon. Oh, no, semicolon on the outside. Is the end of that. But it needs to reassign the value to Z. So then we need to also include a section where we set Z length, or Z.length to the one we need. Z.length equals 6. Correct. Oh, yeah. Semicolon. Wonder what people are saying about what I posted. Gordon, the memory's leaking. Wow. That's what people are saying? Whoa. Bro. His base has like 8 centrifuges in it. Goddamn, that's insane. Okay. But the decryption step. We're going to assign Z of exprex of index. Hold on, because there's more to it than that. We need to take a slice of the word that's the correct length corresponding I bet you could do this with a pen and paper. You know, now that I think about it. Why even use a computer? It's basically just Scrabble. But anyway, we need to assign B1 and B3. So we will take the length, which should be 90 or 72, but we need to take the length of the number. We're going to, yeah, this is going to be a lot of steps again, but we'll do B1. We'll assign B1 to the length of A. So whatever read F. Ah, we didn't even include the read F part. So it would need to read F and assign that to A. But it's not even a read F, isn't it? It's right up here. And then it's A equals strip read LM. And if A equals X, then it B equals 0. Copy. Damn, it's 1 a.m. right now. I must need to go to sleep. Bro, go to sleep then. I ain't stopping you, man. Honestly, I should go to sleep, man. Wonder what kind of new batteries I need for this shit to work. Bro, this shit's old. Okay. I wonder what I gotta do tomorrow anyway. Oh man, I don't even know. Oh wow. Alright, let's try this out again. Oh! Where does that happen? There's a reverse in there. Oh, I forgot we even reversed the shit. Bro, this is cursed. Anyway, we need to assign an A length. But to get an A length, you need to have an original A. So for decryption, we'll just copy that shit. Copy this. We'll scroll all the way down. And we'll enter it in here. Before that while loop. Backspace. Actually. After this first while loop, paste the second one. And then we'll add this shit. Adds an else. And this corresponds to the... Oop. Nope. That ain't quite right, guys. That else statement's not quite in there real good. There we go. That means this one corresponds to there, and this one corresponds to the top. Fixed it! Wait, where does this one go? Ah, perfect. Voidman is at the bottom. And then I can hit tab. Tab, 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 tab. Alright. Then it runs else b2, does the whole, this shit, which will be the decryption. Decryption phase 1. Getting rid of 6. Well, first step. We're going to divide by 6, because it should be in parts of 6. And then we're going to do the steps in reverse. So a dot length divide by 6, right? That should give us an answer to what the entire thing is, what the slice will be. Actually, that's going to be B1 equals, and get rid of that shit. That's a declaration. Why would that be like that? We're going to cut this out, backspace. We're going to hit equals, and then we're going to paste it right back in there. Paste! Post! Oh, well, we might as well just write it out inside of a bracket. A dot length. Yeah, actually it will be in the bracket. So it'll be A dot length divided by 6. Which should give us that, what B1 will equal. B3 is going to equal B1. Just like before. Which is just algorithmic shit. Math! Arithmetic! Algorithmic? Bro, fucking dying. I'm dying. Help me, please! The pain is unreal right now. We've just reached a new level of pain. Reverse steps. Walking backwards can't be as hard as walking forwards, right? Totally. So we're gonna take S should equal S length should equal nothing. We should have nothing on S length, and then S length should be just 0 by this point. But just to make sure, we're gonna assign S equals A dot dupe. just to make sure it's cleared out, equals a dot dupe, semicolon. We're not going to reverse it. And then it's time to remove all of the bullshit. Alright, so that's done. And then usually we do m.length equals 0. Equals 0, semicolon, and a.length. And we'll also say that z.length. But z-length doesn't matter, like I said. It just looks better to have it be equal to 0, in case you were doing shit before. And it was helpful for debugging. Setting it to 0 helped out with the debugging process, for sure. Can remove most instances of z.length. Actually, no. We'll just put it back. We'll just leave it as is, just in case it breaks something. I don't want to break something and miss it. Alright, that should be all of the initialization we need to do for this. The first step, easy. Bro, this shit's fucking crazy. What the fuck? Bro, he has fucking 3 assembly machines. What am I talking about? Let's get back to the programming. I mean, it's basically just the same shit in reverse, right? Basically. Then we have to do it all in reverse. Alright, so then it would be like m equals... We'd literally just copy and paste the, the whole fucking shit for this. Yeah? Yeah! Yeah! I think we can do this. And then each time reinitialize so it makes really easy. That should be good. Then decryption should begin there. So let's hit X to quit. DMD encrypt.d d./encrypt, and we're gonna hit 2 this time. What we're gonna check here is that it does it in the reverse order of the original, right? So if we want to get it in the reverse order, that's what we want to do. So we want to put in our original shit, which I do have still. Hopefully it is still in ASCII characters. I'm gonna just copy text, paste text, and then we want to reverse the first 6. Which did assign it. Then we need to compile these back into its original form. So we would take that compilation step, right? Where is it at? immediately, we could just literally take that shit. Whoa! The one that says right line compiling. Copy that. And paste it in there. Backspace. I think that will do it. Control S. And then compress it. Or actually, X. Hit X. dmd encrypt.d /encrypt. We're going to do 2. And then we are going to... Okay. Compiles out that shit. But then, of course, we will take the great shit and put it on. Actually, here's the thing, though. Does A get set to 0 before each iteration, or no? Who knows? Who knows? Copy text. Paste text. Then... it would appear to have done something of the sort. And I think the last number is 2. So when it does the decryption, we should just get the opposite of what we had before. Kind of. I think it did it correctly. I have no idea if it's doing it correctly at each stage. But that doesn't look wrong. I hope it works. Good God, though, it's insane. So if step 1, I guess, is done, then we need to move on to step 2. Now, I would be kind of worried, because A could be already assigned before compilation of this. So I would want to have a.length. Oh yeah, it does. It does clear it. Okay, good. Oh yeah, it would get reassigned anyway. Okay. So that part's done. And then we just have to redo all this shit. So what we do is copy and paste this in. Where does this correspond to? The first else loop? Okay, cool. Yeah, so we just take all this, select it all. Copy. Shift and enter, backspace, and paste. Now we're going to redo it, but for 9. And it's going to be Fundex now. So that should work. And good God, will it be a pain in the ass to debug this shit, bro. Debugging, oh God. 9. Until B2 equals 0. And then until B2 equals 9. And then stop, and we'll have to hit X to DMD compile the encrypt.d. And then 1 encrypt, 2 decrypt. Out of bounds exception. Array index 8 is out. Oh, it's not being assigned the correct array length, which is 9. Actually, 8. Actually, it is 8. I'm pretty sure it's 8, guys. Actually, no, it's 9. I hope that's correct. Two. No bugs. We're going to take the original text, copy it, paste it in, and see if it works. Gets us closer to what we had before. And I'm going to be honest, I have no idea how close that is. I'm just going to go out on a limb and say it's probably a lot closer than we had it before. Let's go ahead and hit X. Let's do dot encrypt, and let's do 1. Okay, let's go ahead and put in, Gordon, how do I decrypt? I'm gonna copy this shit before I run anything. Actually, hit enter. Yep. Then we'll copy this. Actually, take a picture of shit in here. So after before it gets to length, it gives us this, which is the final output. So we'll have to find those, like the actual full compile versions. Clank, and then the last one was plank, or before, that was before this shit, plank. Current operation was fundex. Where's xprex? Okay, here we go. Cool, copy this one. Paste it. That's fundex, and then xprex. Gives us that one. And then, bro, I'm using Discord as the notepad. And then take then take that one, copy. And then we'll put it in here. Actually, X to quit. What the fuck? Okay, I guess it wants to encrypt X. Who knows? Whoa! Dot encrypt. Dot decrypt. 2 is to decrypt. Paste that in there, and it should give us that first one, the shin. No, it's not working like it's supposed to. Okay. Well, I think I'm done for today. I think I'm burned out, bro. I fucking programmed for too long today. Well, inverting, reverse, actually. So in the compiling step, it goes up. Should I want it to go down? Should I want it to go down? If, then at 14:17, started asking him what others could. Okay, I don't know what I want to do with this. I think I'm gonna take a break. Gotta come back like a month or 2 from now and be like, man, this fucking shitty ass 200 fucking line program, bro. Fucking hate lines of code, bro. Fucking hate that shit. Then yeah, but thank you all for watching.